10th of September 2008, a hot day in Venezuela. A huge white swing-wing aeroplane with a red star on its tail lands at the Libertador Air Base. It had flown from Russia halfway round the world to participate in a military exercise in the Caribbean region. The transatlantic flight had taken 13 hours. In an unusually romantic gesture, the Russians had called this graceful aeroplane the White Swan, and you can see why. But severely practical NATO Soviet watchers originally gave the TU-160 strategic bomber the more prosaic code name Blackjack. TU-160, the White Swan. The TU-160 story dates back to the mid-1950s, a time when the Cold War was ramping up. Both sides were rapidly building up their forces with jet aircraft and anti-aircraft missiles. This confrontation needed more armament, more resources, more money. Atomic weapons became a crucial factor in this military race. The thermonuclear bomb was clearly a significant weapon, but you needed a fast, long-range, high-altitude strategic bomber to deliver it. Several Soviet aircraft designers were developing just such a bomber, amongst them the Tupolev Bureau. They started working on the concept for a strategic supersonic nuclear bomb delivery aircraft in 1952. Project 108 was the first result. That concept envisaged a bomber that could take off from the USSR, attack a target in the USA, and return home. That developed into the more advanced Project 135. But by the end of the 1950s, the Nike Hercules ground-to-air missile, as well as the Delta Dart supersonic interceptor, were coming into service for the United States. The combination of the two systems was enough to deter any strategic supersonic bomber. Projects 108 and 135 were shelved, but all the technical documents were kept in store. Projects 108 and 135 actually shaped the design of later Tupolev multipurpose strategic bombers. 135 in particular helped to clarify how an aircraft like that could be used tactically. That had been the general idea of these concepts. So the intercontinental ballistic missile took over the nuclear strike role. And strategic bombers were sidelined. But soon after the Cuban Missile Crisis, some politicians and military officers alike quickly realized that a strategic bomber still had some advantages over ballistic missiles. Bombers are a handy weapon to demonstrate your military strength to a potential enemy. Unlike missiles, they can fly up and down borders for hours while politicians get on the phone to negotiate and solve the problems. Then the bombers go home. When you launch missiles, you can't do any of that. When Nikita Khrushchev resigned, the new top leadership decided it was time to modernize the armed forces. That included the air forces, of course. But there was no serviceable design for a new Soviet strategic bomber. And not only that, but the revolutionary B-1 nuclear bomber was under development in the United States. That had Soviet leaders badly worried. The military parity between the US and the Soviet Union was getting out of kilter again. The commander of the Soviet long-range Air Force, Colonel General Vasily Reshetnikov, was well aware of the need for the new bomber, probably better described as a fourth-generation strategic weapons system. He had 3 design bureaux to choose from, and Tupolev, one of them. Tupolev's wide experience of designing and building bombers stood them in good stead. In 1974, not long after the death of Andrei Nikolaevich Tupolev, his eponymous design bureau was selected to build an aircraft better than the American B-1 bomber. The Soviet long-range Air Force issued a demanding specification. The bomber would be required to carry various missiles and bombs, to have intercontinental range, and to be capable of supersonic speed at high altitude. It would also need to be able to penetrate air defenses at low altitudes and to have good short-field takeoff and landing runs. This combination of capabilities looked impossible to achieve. You could do it with 2 different aircraft, but not with 1. Chief designer Valentin Bliznyuk had the unenviable task of making it all work. Dozens of different aerodynamic designs were looked at by the Tupolev Bureau and by the Central Aerohydrodynamic Institute, SAGI. They eventually plumped for a so-called lifting body configuration. That means it's not just the wings that provide the lift, but the fuselage as well. And one advantage of that aerodynamically shaped fuselage is that there's lots of room for fuel. Other benefits of that shape were reduced visibility to radar and infrared, and more efficient use of the airflow around the aircraft. Variable sweep-back wings added further flexibility to the flight performance. The aircraft became known as the TU-160. The variable sweep-back wing was one of many design characteristics that we looked at. It's not easy to make it work. And we were facing quite a few other challenges as well, of which weight restrictions were just one. We had problems to solve that we'd never seen before. The Tupolev Bureau had historically been conservative in its aircraft configurations, but this fourth-generation missile carrier called for a whole new approach. They weren't alone in their task. There were lots of other organizations involved. In fact, the whole project embraced more than 800 scientific institutes, design bureau, and production plants. Petro Dementiev was the minister for the whole Soviet aviation industry. He played a great role in the development of the aircraft. He helped us a lot, particularly in our dealings with the other companies. Once the general layout was settled, the aircraft equipment had to be developed. The TU-160's fly-by-wire flight control system meant that it handled like a fighter. Despite its huge weight, it was a very easy aeroplane to fly. It was an innovative bomber in all sorts of ways. The interesting thing about this airplane was the control system. The young pilots would get very excited about the fighter-style control stick. The old hands were used to a good old control wheel, and they didn't like the stick. But with fly-by-wire, you didn't need the big control wheel. Flying this heavy bomber didn't require old-fashioned muscle power. It's almost as if the pilots could control it with their minds. It was a complete departure from our earlier bombers, which didn't have fly-by-wire. With this system, you just needed very slight movements of the stick to control the aircraft. At the end of the day, any strike aircraft is just a weapons delivery vehicle. But nowadays, the vehicle is not just a bomb dropper like it used to be. Modern strike aircraft carry high-precision, highly accurate weapons. They were designing aircraft like that in the US and Europe, as well as the Soviet Union. There are more than 100 digital computers in a TU-160. They control everything from the aircraft's attitude during flight to setting the parameters for cruise missile guidance systems. The first TU-160 was built at the Tupolev Bureau's own production facility, right in the center of Moscow by the Yauza River. Then it was taken apart and delivered to the Zhukovsky test airfield by truck. ground tests complete, this extraordinary aeroplane was ready for its maiden flight. 4 men on board, test pilots Boris Feremeya and Sergei Agapov, and test navigators Anatoly Eryomenko and Mikhail Kozel. 18th of December 1981, a cold day. The TU-160 taxis out to the runway at the Flight Research Institute. The aeroplane hasn't been painted yet. The 160 soared skywards with a huge roar from its 4 engines in full afterburner. The takeoff thrilled everyone who was there to see the maiden flight of the new bomber. Before the test flights, one foreign aviation magazine had published an unauthorized picture. It showed the ramp at the Flight Research Institute. Alongside the well-known TU-144 supersonic passenger aircraft, there was a very strange plane, a bit like the American B-1 bomber. Well, maybe their outlines are similar, but these are completely different aircraft. The TU-160 is much bigger than its American opponent. Its flight performance is different as well. I'd say our TU-160 is better than the B-1. It's more advanced, it's more innovative. Obviously, strike aircraft have to carry as many and as great a variety of weapons as possible. The 160 can carry 22 tons of different weapons. It has a range of 14,000 kilometers and its maximum speed is 2,000 kilometers an hour. The American B-1 is somewhat less of a performer in most respects. TU-160 mass production started at the Kazan aviation plant. Even the manufacturing process was innovative for the Soviet Union. Amongst other things, the design included titanium welding, composite materials, and triple sandwich construction. It's no exaggeration to say the TU-160 was a wholly revolutionary aeroplane for Soviet aviation. This is a unique aeroplane in many respects. The TU-160 Intercontinental Strategic Missile Carrier. Wingspan with 20 degrees sweep, 55.7 meters. With 35 degrees sweep, 50.7 meters. Fully swept back at 65 degrees, 35.6 meters. Length, 54.1 meters. Maximum takeoff weight, 275 tons. Maximum speed, 2,000 kilometers an hour. Cruise speed, 1,030 kilometers per hour. Practical range, 14,000 kilometers. Service ceiling, 15,600 meters. Payload, 22,500 kilograms. So let's look at some of the details of this unique supersonic strategic aircraft. The advanced radar antenna operates within the radar transparent nose cone. In the fuselage, there are the cockpit flight deck, 2 weapons bays, the fixed wing, the center wing spar with the wing sweep pivot fittings, the variable geometry sweeping wings, and the engine pods. At the back of the aircraft, the housing for the braking parachutes and the Baikal onboard self-defense system. That detects air defense radar threats and then jams them. It can also fire decoy heat flares if necessary. The Ogonyuk thermal detection system is in the end of the tail cone. That detects enemy missiles and aircraft approaching from behind. 3 X-shaped braking parachutes significantly reduce the landing run of this heavy aircraft. The low-mounted center wing section blends with the fuselage, and outboard of it are the variable sweep-back half wings. There are low-speed, high-lift devices on the leading and trailing edge of the wings to provide good takeoff and landing performance. Boundary layer fences operate as the wings sweep back. In the fully swept back position, the fence improves the lift-to-drag ratio. These computer graphics show the neat mechanical operation of the boundary layer fence. The tailplane is an all-moving horizontal stabilizer. The tail fin is an all-moving vertical stabilizer with the added advantage of extra radar stealth. The nose wheels have special protection flaps. They stop dirt and mud and stones getting into the engine intakes during takeoff and landing. The NK-32 engines, NK for Nikolai Kuznetsov, their chief designer, are the most powerful engines ever fitted to a combat aircraft anywhere. Each engine produces 25 tons of thrust in full afterburner, so total thrust is 100 tons. Ground run-up produces a dust storm behind the aircraft. The engines are in 2 underwing pods. The engine intakes have movable wedges that optimize the intake performance in different flight conditions. The fuel tanks are front and rear in the fuselage body as well as in the wing. They can hold a total of 171 tons. To improve engine performance, the fuel is nitrogenized on the ground before the flight. It's the nitrogen that gives the exhaust plume its distinctive reddish color. This is the probe of the probe and drogue air-to-air refueling system. And there's the drogue on the end of its hose. The refueler is an IL-78 tanker. Enough fuel on board, the probe disconnects and then retracts back into the nose of the 160. The pilot's seats at the front of the cockpit. The navigator and the defensive systems operator sit behind them. There are 4 K-36 ejector seats. They provide safe ejection from the aircraft for all the crew at any altitude and even on the ground.
The
cockpit ergonomics are great. It's simple. The main flight instruments are on either side of the central panel. These are the flight control instruments: airspeed indicator, altimeter, climb and descent indicator. You need good piloting skills and a depth of engineering knowledge to command an advanced aircraft such as the TU-160. The aircraft commander needs to be a skillful and experienced pilot. He's carrying a nuclear weapon with the same sort of power as the submarine ballistic weaponry.
Показывающие положение стабилизатора, наши авиационные часы.
Of course, the 160 is stacked with clever avionics and other sophisticated stuff. But it's got some other things that no Soviet bomber had before. There's a crew rest area and a lavatory to help cope with the long flights. There's even a little galley, because during those long-range missions, comfort is a precious thing. Pilots are human, they're not robots. This is an electric oven, so we can have nice warm meals on board. Good stuff. Next to it, hot water for a nice cup of tea, if you like that. Of course, the whole point of the TU-160 is its weaponry. Primary armament is the KH-55 strategic cruise missile. It combines a relatively small nuclear warhead with a distinctive aerodynamic layout. It's got a single turbofan engine stored inside the missile, and before launch, the engine pops out. After it's launched, the wings and tail surfaces deploy. The KH-55 missile uses low-level terrain following, flying as low as 100 meters above the surface, at speeds of about 850 kilometers an hour. When it's flying over the sea, it uses an inertial guidance system. With the missile over land, the terrain contour matching guidance system kicks in, and that navigates to the target by comparing its radar picture with images stored in its computer memory. All of that allows the missile to get itself to the target with high precision. Despite our early doubts about it, the KH-55 is unique. But earlier missiles were much faster, 6,000 kilometers an hour or so, and they could fly up to 20 kilometers high. The KH-55 could only do a mere 850 kilometers an hour, and it flew at low level. And we couldn't understand how a missile with such awful performance could have come into service. But later, we realized just how effective a missile it is. First of all, it's low observable, stealthy, and another thing is its range. Earlier missiles could go 600 kilometers at most. This one can do more than 2,500. It's very simple to maintain. Earlier missiles were tricky to maintain. Technicians had to wear protective suits because of the missile's toxic fuel. KH-55 uses plain old kerosene. They're also easy to load. With the old KH-15 missile, technicians had to take their coats off to reach the suspension points. That's not good, especially in winter. KH-55 is loaded quite differently, smooth and easy. The TU-160 can carry 12 KH-55 cruise missiles. With their wings and tails folded, they're suspended on two rotary launchers. Each internal bay holds one launcher with 6 missiles. Here's a simple scenario of an attack with KH-55 missiles. Before flight, the specific data is loaded into each missile. 6 missiles are launched, and the aircraft is free to leave the launch area. The wings pop out, the engines power up, and the missiles set course towards the target. During the flight, the missiles change position and even shelter themselves behind each other to avoid radar detection. As they approach the targets, they spread out. Some will get hit by enemy air defense weapons, but others will penetrate the air defense system and hit their targets. The TU-160 can also carry free-fall dumb bombs and other weapons. It has an electro-optical bomb sight. The navigation and weapons aiming system are combined. Along with older gyroscopic instruments, the system also includes a star tracker. The TU-160 was the first Soviet aircraft with a satellite navigation system. The system was specially developed for the 160, and in fact it predated the American GPS and the Soviet GLONASS systems. So the new bomber was replete with the latest technologies. By the mid-1980s, the TU-160 was the most advanced Soviet aircraft around, with much use of state-of-the-art avionics and other cutting-edge equipments. New aircraft always have teething problems, and the 160 was no exception. But with the test program in full swing, the military and political situation changed. The military authorities couldn't wait. They decided their newest aircraft had to be delivered to a combat unit. It was an enormous risk, but it turned out to be justified. So, military crews had to develop new skills to carry on the testing program of this new generation aircraft. 184 Bomber Regiment, based at Priluki Aerodrome in the Poltava region, was the lucky unit chosen to receive the Tu-160. The aircrew and the technicians were sent off to the Kazan plant to bone up on the Tu-160 design. They also went to Kuibyshev, where the engines were built, and even met the chief engine designer Nikolai Kuznetsov himself. The aircrew also studied the new aircraft's navigation and weapons systems in detail. By early April, 184 Guards Bomber Regiment was ready to host the new strategic bomber. On the 17th of April 1987, the first two mass-production aeroplanes landed at the Priluki Aerodrome. Major General Lev Kozlov flew the first aircraft in. He was then the 37 Air Fleet Deputy Commander-in-Chief. He became the first Tu-160 military instructor. Just 2 months later, the regiment aircrew achieved the first Kh-55 missile launch from the Tu-160. The military aircrew had got comfortable with the new bomber very quickly. Things were moving now. The Tu-160s started flying long distances, day and night. The aircraft seemed set for long service to the Soviet Union. But the USSR disintegrated in 1991, and Soviet aviation as such was finished. They'd originally planned to build about 100 of them. By the end of 1990, only 35 had been made. As the Soviet Union splintered, 19 of the 35 aircraft found themselves stationed in the newly independent Ukraine. In April 1998, Ukraine decided to start scrapping the bombers under the Nunn-Lugar International Cooperative Threat Reduction Agreement. In November 1998, 11 aeroplanes worth more than $2 billion were ostentatiously chopped up at Priluki. The United States provided a special metal cutting machine. Only a few of these strategic missile carriers remained in Russia. They were stationed with 121 Guards Heavy Bomber Regiment at Engels Air Base. By 1994, the regiment had got 6 of them. In 1999, Russia offered to buy 8 Tu-160s back from Ukraine. They eventually signed a contract to pay $285 million, which was to be deducted from Ukraine's debt for natural gas. 6th of November 1999, the first repatriated Tu-160 arrives at Engels Air Base from Ukraine. The other 7 came back to Engels in the following months. By February 2001, the Tu-160 fleet had grown to 16. It wasn't the 100 they'd planned in the 80s, but times had changed. The aircraft began patrolling the Russian borders and the Pacific and Atlantic Oceans. In May 2003, 2 Blackjacks took off from Engels Aerodrome. They headed south. Iran provided a transit corridor for the Russian bombers. They flew right across Iran to the Indian Ocean. It was the first time the Russian bombers had flown to the west coast of India. On 10th of September 2008, 2 Russian Tu-160s landed in Venezuela as part of a military exercise. As usual, they'd been shadowed by NATO fighters as they flew over the Atlantic. But to the surprise of the NATO pilots, the Russian bombers hadn't turned for home, as they'd always done before, but instead continued their flight westwards. The Russian bombers covered the 10,000-kilometer route to the Caribbean in 13 hours. For the crews, it was a routine flight. It was a training mission, but a particular one. Russian bombers had never been to this area before. It was an unprecedented event. It became necessary to test the aircraft in another geographic region. The climate in South America is different. In Venezuela, the humidity is very high, so it was a good trial for our bombers. Another task for the mission was to check how we would provide proper maintenance when the aircraft is thousands of kilometers away from base. From the Libertador air base in Venezuela, the Russian bombers flew for 5 hours off the coasts of Panama and Brazil. The crews tested their equipment and avionics in conditions of high humidity and indeed in tropical thunderstorms. Since 1988, the TU-160 White Swans have appeared at air shows at Tushino and later at Zhukovsky in the Moscow region. They've also flown in the Victory Day air parade over Moscow. They've put on demonstrations for American politicians and military. Senator Barack Obama, the future US president, visited Engels Air Base to have a look at the Russian strategic bombers. In 2005, the president of Russia, Vladimir Putin, visited the Zhukovsky air show. He flew in the Tu-160 for several hours. The Supreme Commander-in-Chief of the Russian Federation must be familiar with the armament in our country's infantry, be it a nuclear submarine, a tank, or a modern combat aircraft. We flew for several hours and we showed Mr. Putin the combat capabilities of our White Swan. We flew the aircraft at high speed. In fact, we went supersonic. We also did a simulated air refueling, which is an impressive maneuver. But I guess the most interesting part of the demonstration was when we launched missiles. Mr. Putin was impressed. We also showed him how we detect surface targets like ships, and we flew at low altitude in the area of Olenogorsk airfield. So during the flight as a whole, we demonstrated all the main capabilities of the Tu-160. When the White Swan landed, the president was told that the Tu-160 bombers were still undergoing prototype testing. He was very surprised. But within a few months, that testing was complete and the 160 officially entered service in the Russian Air Forces. Long-range aviation was excited about that because it had been nearly 20 years since the first Tu-160s had arrived at Priluki airfield in 1987. Tu-160 crews had begun practicing air refueling early in the new century. We started training for air refueling in 2001. First, we simulated it. Then we progressed to taking on 10 tons of fuel. We increased that to 15, 20 tons. And finally, we took on the maximum 50 tons. We asked ourselves how long the aircraft could stay in the air. We didn't want to take any risk, mind. We decided to take on 2 lots of 50 tons each. That should give us about 25 hours of non-stop flight. You might say, why didn't we fly longer? Well, the trouble is the oil, the engine oil, has to be changed or we damage the engines. So we took off and flew just about all round the Russian border. The flight time was 24 hours and 24 minutes. As I said, we didn't want to take any risk. When we landed, we checked the oil. We discovered we could have stayed airborne much longer. When the Tu-160 had come into service in the Soviet era, only very experienced long-range aviation pilots flew it. Nowadays, the aircraft captains are relatively young pilots. Young, but very skilled. Pilots learn to fly the 160 in the flight simulator. It's a near-perfect simulation of actually flying the aircraft. They also practice emergencies like forced landings, for instance. They don't do that in real flight, of course. I think our country's people should be proud of this aeroplane, which serves the Russian Air Force so successfully. And I'm very honored to be a TU-160 crew commander. It's a big privilege to be in charge of such a beautiful plane. It's unique. It's a truly excellent performer. It's more than 30 years since the TU-160's maiden flight. It's been in service for a quarter of a century. And requirements change, so the aeroplane has to be modernized. The aerodynamics are excellent, but the electronic equipment on board needed to be updated. Now the aircraft are undergoing the first stage of modernization. Old units, out-of-date equipment have gone. They've stopped making that stuff. So the aircraft will get a deep upgrade. There'll be new avionics, new weapons control and reconnaissance systems, new radar stations, and the rest. It all has to be done if we want this aircraft to continue to meet requirements. Our long-range aviation crews are expecting to receive their modernized TU-160s in the near future. Technologies develop very fast, and we have to keep up with them. With all these new systems, the aircraft will get a second life. I'm sure the TU-160 will stay in service for many years to come. Each TU-160 has its own name. Russian pilots started this tradition of naming airplanes during the First World War. The most famous aircraft then was the Ilya Muromets, four-engined heavy bomber. Ilya Muromets is the archetypal Russian epic hero. He's regarded as the greatest of all the legendary Russian knights. So his name was bestowed on this TU-160. It had the signal honor of leading the Victory Air Parade in May 1995. Now, every TU-160 has its own name. Mostly they're the names of aircraft and engine designers, commanders and pilots. Here are just a few of them. Long-range Air Force Commander Vasily Reshetnikov, TU-160 designer Valentin Bliznyuk, test pilot Boris Veremeya, Kazan Aviation Plant Director Vitaly Kopulov, engine designer Nikolai Kuznetsov. The history of the TU-160 aeroplane, the Great White Swan, is the history of its people.